All right, welcome everybody. Thank you so much for joining today for Permeable Interlocking Concrete Pavers. This is presented by the team at Unilock. We're going to have Phil Austin giving today's presentation, and we've also got Megan Taylor here from the Unilock team. They'll be here to answer any questions that you have. So please feel free to use the Q&A throughout the presentation to submit any questions. And you can also raise your hand. We'll keep an eye on that. We can unmute you towards the end of the webinar if you've got a question you'd like to ask out loud. Before we go ahead and get started with the CEU approved portion of today's webinar, my colleague Helen is going to give a quick little intro about Acelab and show you how to find today's presenters on Acelab in case you have any questions that come up after today's webinar. And then we'll go ahead and get started with the CEU approved course. All right, Helen, feel free to take it away.
Awesome. Thanks, Bo. All right. Hey, everyone. I'm Helen. I am the Director of Architect Experience here at Acelab. And today I'm going to show you a little bit of what we have coming out very soon. So we'll talk about that. We'll end there. Right now, I'm going to talk about how you can get in touch with the folks at Unilock and then also what to expect after this webinar. So after this webinar, either myself or my teammate Evelyn will be creating conversation for you with these lovely folks. Really encourage y'all to put into that message that myself or my colleagues send over to you where your projects are typically located. That way we can make sure you get connected with a local rep. So expect that. What you'll see is you're going to jump into your workspace and see a conversation with them. And that's how that'll happen. You can also respond directly now from your email and keep a record of that conversation in Acelab. So 2 options for you to follow up and keep the conversation going. And then in other news too, if you want to get in touch with the Unilock folks or understand and see some of their products here, up at the top, you can always type in brands, and then you can jump into their page. On their product page, what you're going to see is another way to contact them directly. You can hit this contact button. Same thing, it'll start a conversation. But you can also learn a little bit more about their products. There's also loaded up some really nice case studies. So lots of stuff for y'all to look at here. And then again, these are all of their products. If you want to see some more, you can always hit that button there. Another really cool thing you can do in Acelab is you can start to compare these as well. So I can save these into, say, a project folder. And what that'll allow me to do is then kind of create a comparison. I'm just going to do this really quickly across these 4 products. And then you can kind of see information. You can leave comments and add documents for your whole team there. They have the BIM and CAD files publicly available, so you can download them here too. And just scrolling on down, you can see all kinds of great information that allows you to really kind of compare and contrast all their different products. So, you know, if we're looking for this kind of a color, we can kind of keep finding other options. So just some ways that you can kind of use Acelab and what to expect after the webinar. Last thing is what's coming up for us soon. So I am running a program right now allowing folks to have early access to this. This is Acelab's scheduling feature coming out very, very soon, about less than a month away. And so what this will allow you to do is kind of keep track of your approvals. You'll be able to kind of import these, export. You can write your materials that are here, all kinds of great information, other projects this has been used in. And really exciting too is the ability for y'all to export this across all of the categories we have currently. And then you can take that into your drawing sets. So this is really exciting. Soon on the heels of this will also be a great jumping off point for your spec planner. So all the products that you save with us, you'll be able to have here. Another export feature available as well. It's a really great jumping point to really bring all of y'all's material workflow within Acelab. If you're interested in early access to these features, and then you get to use them all summer, well ahead of the public launch, then let me know. I'll send out my email here in a moment, but you can also indicate your interest on the poll. With that, I'll let y'all get your CEU credits and pass it over to Phil. Thank you.
Awesome. Thank you, Helen. Yeah, take a look in the chat for Helen's meeting link and set up some time with her if you're interested in learning some more about that. You can also respond yes to this poll that we have up now, and someone from our team will reach out to you to schedule a quick 15-minute session. All right, one last housekeeping item from me. In order to get credits for today's course, there's going to be a short quiz that everybody who attended needs to fill out in order to receive those credits. So we're going to send over a link to that quiz in the chat. We're also going to send a follow-up email after today's webinar where you're going to have a link to that quiz as well. So in order to get your credits, you're going to need to fill that quiz out. You can request a certificate through that as well. So anybody who's looking to receive credits or a certificate will need to fill that out. All right. Other than that, just a quick reminder to please submit any questions throughout today's presentation. That way, if we don't get to your question, we'll have a record of it and we can follow back up with you after today's event. All right. Phil, whenever you're ready, feel free to take it away. And thank you so much for joining us today.
All right. Well, thank you, everyone. Helen and Bo, thanks for the opportunity to present. I'm just kind of getting this going for you on my end. All right. Yeah, so today's subject for me is on permeable pavers. I wanted to make sure that this was a conversation. And so there are opportunities for questions and things that we can review at the end, but more specifically, we're always available to follow up with any specific questions. Very quickly about me, my background is in landscape architecture. And I think one of the advantages that we try to bring is to always be a resource for you and try to speed things up in terms of answering questions, solidifying material selections, bringing past project experience. And that's what a lot of this presentation is based upon. So I live in Pittsburgh. I kind of cover a large swath, and we have local reps throughout the United States that can certainly be a resource for you within your projects. Today's presentation, like we said, is both landscape architecture LACES certified, as well as AIA. So make sure you fill out that quiz at the end, and we will follow up with certificates and make sure you get the information required for your licensure, or if you just need a PDF for self-reporting, etc. As a partner, we do have some different resources available for you, and I'll kind of talk about it, but at the end, I kind of go more in depth on Unilock and products. But we do have two different resources in terms of catalogs. The way I like to explain this is the residential catalog, for me in my world, is readily available material. So regionally specific colors, shapes and sizes, all of that information is for the most part, material that we have at a quick ship opportunity, things that we can make readily available. The commercial catalog is a fantastic catalog of imagery and how shapes, finishes of all different sizes and opportunities come together. A lot of project examples for you to see the opportunities that Unilock can provide for your project, and more information can be provided based on any questions you have or what we're available to provide. We do also have a permeable paver specific, brochure that goes more into depth and really covers a lot of things I can't get into detail in this 1 hour presentation. So this is a great resource for you to review, understand the content, and certainly have at your disposal for any immediate questions. Some of the learning objectives are kind of obvious. We'll talk about, how to go through and work through the system. But I think these are really important for me, is understanding the design consideration, what goes into a permeable paver, what's different from a traditional system. I have some very specific case studies where permeable pavers were used to meet a specific need within the project. We talk a little bit about installation opportunities. I touch on maintenance because I think that's a really big topic for our clients to be educated on and for us to understand how these can be long-term solutions. That will be the break of what I can consider the CEU portion. And then if you want to stay on, I really encourage you to. I just quickly cover some material options more specifically, and there's a lot more product imagery to better showcase all of the options that are available for you. So from a general information standpoint, I think there's a big complexity with doing a virtual presentation because I don't know all your familiarity with permeable pavers. Some of you here today might be learning about permeable pavers for the first time, and others might be returning to gather more information from previous projects and what to learn. So I think the starting point for me is permeable pavers make sense for an ever-changing climate. And what we're seeing today is that as the climate continues to change, the regulations by which we're designing for stormwater aren't keeping up. So as we design for the current standards, the storm system is already outpacing what we're designing for. And that's leaving with us with a lot of flooding of our communities, damage to our streets and towns, just like this image here. And I think the benefit of what we're going to be talking about today is that it's ever improving with this changing climate. And this isn't my perspective on climate. One of the things that we really try to stress is that, I'm more of the East Coast, so I can't speak to every community, every region, but we're seeing a change of precipitation that's impacting our local communities. The storms are getting more intense, the volume is more frequent, and all of that has a negative impact on our developed areas. As we develop these areas, often I think upon my community and I see what used to be woodlands or farmland or grassland that could handle these storm events, and now we're changing that into developed area with more impervious cover, and that is directly relating to the amount of runoff that has to be captured, has to be basically quantified because of that development opportunity. And that's where permeable pavers really coincide with the development we're already trying to create and the solution built in for how we handle that stormwater simultaneously. This is an image that I kind of gathered from my local stormwater community, and it just shows what happens in more urban environments between capturing water off the roof, off the street, off the parking lot. All that captures into the storm drain, which inundates these antiquated combined sewers. And unfortunately, the result is all that water finds the next closest water body. It could be the Chesapeake Bay, it could be the Great Lakes, it could be the Ohio River, it could be the Mississippi. And just staying on the rivers, for example, those aren't a closed end solution. Unfortunately, they all lead somewhere. Again, whether it's the ocean, the Gulf of Mexico, for example, as I have shown here. And those are creating devastating effects downstream that it's an isolated problem for the community that's becoming a more regional problem for all of those interconnected water bodies. The other way that we handle stormwater is we dedicate land to this infrastructure need and requirement. And basically what we're doing is we're saying, all right, we've got this impervious building. We've now built this impervious parking lot, and we're going to dedicate a piece of land to capture that stormwater. And I think there's some real issues with that as to how we think about development. One of those is that land could be sellable, back to usable land for the developer to use as more opportunity rather than just infrastructure. So if we're already developing area, why not use permeable pavers and help meet that solution within the opportunity, I guess. I think that's a really good time to talk about what permeable pavers are. Again, not knowing your personal background, I think this is a really good kind of cartoon overview in identifying that the whole system is open graded, which means allowing the water to work its way through from the top down. So in a traditional system, we'll talk more about this, a traditional system requires sheet flow to a drain where we're capturing the water. A permeable system still has that dense, hardscape paver with enlarged joints that allows the water to move through the surface down into that base, which becomes our reservoir. It helps us to eliminate that detention pond or eliminate any additional storage tanks, and all self-contained within that permeable base. Maybe it's my landscape architecture background, but I think the reality of what happens with green infrastructure when we start thinking about open idea solutions to handle stormwater is that there's no one silver bullet. I think all strategies have to be at the table, including permeable pavers as well as vegetation. And oftentimes I think they're mutually beneficial. It's not an exclusivity requirement. So a lot of times we see permeable pavers with bioswales. We see permeable pavers with other vegetation opportunities because they help benefit the overall project as well as the solution for each other. Just a quick overview for me. I think pavers in our minds We hear concrete pavers and we think about our backyards. And yes, we certainly do a good job of doing that. But I think pavers have this commercial application that needs to be understood and explored. Some of these are from, from our yard where we're loading pavers onto trucks every day. Others are from, industrial applications where there's heavy vehicles, heavy use. So we can certainly meet those criteria, in addition to bringing forth aesthetics and character and identity to a project and to a place. I think this is a really great example from a campus in Chicago where there was flooding as a concern on campus, and permeable pavers were a method to provide the solution for that stormwater solution, but also to bring forth the aesthetic that the campus was looking forward to. And with Unilock as a partner and the landscape architect on this project, we were able to execute something that really brought vibrancy to the central part of the campus while meeting that ultimate goal, which was solution for that stormwater problem. Moving into design considerations, for me, this is really the backbone and understanding how we make these selections, but how we detail this. I thought this was a really good place to start for us because whether we go to Acelab or we go to the Unilock website, I think there's always a starting point of what am I looking for? How do I get to what I need? And we really have to kind of work through this process of what am I selecting? And I have to understand right away whether I'm working with you or you're working, late at night and making selections. Am I choosing a permeable paver? Am I choosing a traditional paver? And the separation for me is that starting point, because I need to know how it ultimately works to choose the right material. So permeable paver, as we talked about, is letting the water move through it. Traditional pavers are keeping the water at the surface and draining to a slope. Next criteria for me is application and understanding, are we vehicular? Are we pedestrian? If we are pedestrian, will there be garbage trucks or will there be some sort of maintenance that might not be the dominant use, but still has an application on that surface? So we have to unpack and understand how these places will be used before we even get to, well, what colors are going to be? What do we want it to look like? First, for me, comes function, then comes aesthetics. I chose this picture because as I was building this presentation, it kind of reminds me that whether we're doing a really quick rendering or we're doing a sketch, a lot of times people choose this front material, which is more like a lattice work where they show grass filling the paver. And I kind of have to laugh at this picture because it's from the internet and I didn't make it and I don't know who did, but there's a ton of birds in this picture. It's really bizarre. But my attention to this picture was that everyone thinks that they have to start with this turf paver as a permeable paver. And it really, it's an old paver. I don't blame you for thinking that's the only one out there, but the industry has evolved so much from this. And I have to kind of pause and say, this is a usable paver. We still make this today, but it has restricted use. It's not going to be your everyday parking lot paver. It's not going to be your everyday roadway paver. It's going to be overflow. And when we specifically fill it with grass, we are not a permeable paver because ultimately we're not letting water move through as rapidly as we would want. We are having the same coefficient across the surface as a lawn area. If we want it to be a permeable paver, it needs to be filled with aggregate, which is more like the picture on the right. So understanding even what this is and how it works, there are better options that we can understand later on. As I said, when we're making that selection, the starting point is understanding what road to go down. Am I traditional or am I permeable? So I pause on this detail and I say, all right, this is our traditional detail. And there's variations of this that we can explore at a later time. Generally speaking, starting from the bottom, this is a dense graded aggregate, which means it has fines included into it and it gets compacted really tightly. So we're not letting water go through it. The second layer is that it's a sand setting bed. That's a traditional method that's been around since pavers have been installed. And the third component is sand in the joints. All of those three things together mean that we're keeping water on the surface, we're having a slope to that hardscape, and we're directing that sheet flow to a drain. Right there, that's traditional, and we are not permeable. All pavers are not inherently permeable. Switching gears, when we go into a permeable system, for me, it's kind of like how the Romans built roads. So we have larger, coarser aggregates at the base, and we get to smaller sizes as we move up. The main difference is there are no fines in this entire profile. So there's no fines in the aggregates. There's no sand. We won't use the word sand in a permeable paver system, and there's no sand in the joint. So all of this entirely is aggregate. I show this detail because similar, and I'll just kind of pause there, but there's no one detail I'm going to share with you for a permeable application. We have to understand the use, and that was kind of the second criteria. So once we've identified that we're a permeable project, I now need to understand application, and that's going to help us to determine the depth of that cross section, because remember, this is our detention now, so we not only need to think about it through a lens of structural performance, whether it's a parking lot or a roadway, but we also need to think about it from a capacity stance, which is how much volume does that base have, so that we know what kind of design we're designing for within that storm event. So this is just a generalized typical detail saying, here's your layers. We need to hone in on what those layer thicknesses are. I feel like this image helps to identify what these materials are. So if we start at the bottom, we use ASTM because it's more universal. And as each of us know, each state, each location has different names for the different aggregates based on the quarries. So we use ASTM as a more universal kind of national language. ASTM number 2 is about fist size, and you can see it's all limestone. So all this throughout the entire profile is limestone. I don't want to really get into the other materials conversation. We can explore that on a project, but the starting point for me always is crushed angular limestone, and you can see again no fines, and it's washed material. So bottom layer fist size, number 57 is 3/4 inch, and you can again now you can start to see how you have those larger aggregates on the base. They start to choke off as you top off with the 57s. That's about 4 to 6 inches. And then you go to your setting bed, which is more of a constant. It's about 1.5 inches, 2 inches at the most. And that chokes off the 57 layer. So they all kind of work in harmony to build that totality of the cross section. The reason that we have these larger aggregates on the base is that's where you get the maximum void space between the aggregates where the water can fill, and it helps to provide that structural performance for loading so that we're not putting this dense load into the subbase, which would ultimately compact. We're keeping that pressure from vehicles and from traffic flow, for example, off of that base to allow for maximum infiltration. I felt like this was a pretty good chart for you just to see how variable based on application, the depth of a typical cross section could be. So when we talk about a sidewalk, we're purely pedestrian, and you can see we're pretty low in terms of overall cross section depth of the 57 stone. 10 inches is a good recommendation. And then you can see all the way up to heavy duty industrial, where we could be a total cross section of base and subbase of 20 inches. These aren't factoring in the setting bed and the paver, so by the time you factor those things in, we're about 24 inches total cross section. Felt like it was important to share with you some resources that we have online, because as we design these systems, we don't always know the answers immediately, and this is a resource to kind of help provide those solutions. So starting from our website, when I went to resources, I'm able to choose onto stormwater volume, and it creates a chart for me. And I just plugged in some typical data. I just, used a rough 15 space parking lot, double bay, came up with 64 width. I put in a 24-inch sub base, and ultimately, sorry, kind of forgot that I had some transitions. Ultimately, I was able to provide for you to see how much capacity is in the system. The point that I try to make with that is, generally speaking, within the aggregate alone, we have enough capacity and storage space that we don't need additional storage tanks, and there's not a need for an additional detention pond outside of the base that we're building. And all that depends on the volume that you're trying to hold, but also the space of the pavers and the depth, and you can kind of see that within this chart very quickly. So this is a little bit more in depth on that number 2 stone. This is the base layer. This is the most variable for me. So this is where we will change the volume that we need based on the amount of space that we need based on that chart previously. The 57 stone is that middle layer. Where I would go with this is that it's a little bit more of a constant. I would say 4 inches the minimum, 6 inches is the maximum. You don't really want to vary too much on either side of that. I don't like a full cross section of just 57 stone for a vehicular application. We really want that structural reinforcement for the larger aggregates on the base profile. When we do need additional structural reinforcement, I think that there's a product out there that we partner with that's a really great solution. So coming at this from the lens of a parking lot and a normal traffic pattern, the parking lot can hold up perfectly fine for an extended use. But there's that garbage facility in the back corner where the garbage truck every week needs to drive down the same travel lanes and go pick up that garbage collection. This helps to reinforce that base material so that there's no rutting long-term of this base profile. So I often introduce this grid into that 57 layer and provide additional structural reinforcement beyond just the aggregate alone. So that's something that we can bring to the table for these high-use, heavy trafficked areas so that we have this performance that lasts the lifetime of the project. As I moved up my different aggregate layers, I'm now to the setting bed layer. And again, different from traditional, this would normally be a sand setting bed. Now we are, a 1/4-inch chip aggregate that creates that flatness for the pavers to set on, but also allows the water to move through rapidly. In the world of details, never does an open graded base meet with a sand setting bed. Those two do not meet. So we have this open graded chip that chokes off the 57 and allows the pavers to set on top of it. So I kind of moved up through the different aggregate layers. The next component of this detail that's important for me is edge restraint. There's 2 different ways based on application. Vehicular, I always recommend a concrete curb. And what I'm showing in this detail is the pavers on the left, the flush concrete curb, and then it could be either new construction or existing asphalt. I have project examples of both. But you need this concrete curb, and because the 2 worlds are very different, permeable pavers and asphalt, we need that curb to help separate as well as structurally reinforce. There's going to be maintenance for both down the road. That curb helps keep those 2 worlds separate, in addition to providing that performance of locking the pavers and the aggregate in place. So this would have been a new construction next to asphalt. This was a streetscape project I worked on in Pittsburgh where the parking stalls are permeable and the main roadway was traditional asphalt. So the edge restraint for pedestrian looks a little bit different from vehicular. And we don't need that massive deep curb because we don't need that expense and we don't need that level of performance for pedestrian use. So I actually recommend a product that's troweled on. And it's not like going to Home Depot and picking up a bag of Sacrete. This is specifically designed for permeable aggregates and helps lock everything in place. But it's as simple as that little cartoon detail I put in this presentation of a troweled wedge that locks into the base material. and at an angle holds the paver in place. So for pedestrian applications, I would strongly recommend identifying what the edge restraint is, preferably using something like this. Here's a real world installation showing how, ultimately the pavers are locked in place, and then the lawn or the landscape will go right over top of it and hide that from visibility. The last component that I think is extremely important to understand in a permeable application is the joint material. So similar to the differences between a traditional, this would normally be filled with a polymeric sand in a traditional application. And what you can see here is how it's done again with that open graded aggregate. So we can get a small enough aggregate between any size paver, and that allows the water on the surface to move through. But it's also doing something else that I think is extremely critical. Now, I'm a little bit older, so in my world, we used to have what's called the Brita filter in our refrigerator, and that purified the water as it moved through. So too does this joint material. It's keeping the mulch, the cigarette butts, the parking lots are disgusting. If you've never just taken a look at them, there's gum wrappers and straw wrappers and leaf litter, and all that stuff would otherwise be working its way into our base profile. But this joint material is keeping all that on the surface where it can be easily maintained and taken care of. There are products out there that I strongly have issue with because they don't have that joint material. And all that debris that I just talked about gets into those joints and ultimately gets down into that base material where it is much harder to take care of. So we have to understand the reason why, and ultimately these still perform at a very high level and expose the opportunities for where maintenance needs to be done so that it's part of the solution, not a part of the problem. I threw this slide in because sometimes aggregates for the joint material can be granite chips that can really enhance the project. So whether it's a contrasting color, something of importance, that's an additional design element. So I focus on two quick case studies. The first one is in Pittsburgh. It's a streetscape, and ultimately it was chosen because they needed a stormwater solution. So if anyone's familiar with Pittsburgh and Bose and Philadelphia, I'm sure there's similar streetscapes in a lot of these older communities that are 100-year-old brick, and they are fantastic until they're not. And we're reaching the point where they're no longer fantastic because utility lines have to go in and repair. They've reached the extent of their life expectancy, and we're starting to struggle with them. So the city had to go in and make a repair because the gas line was fixed. And you see this asphalt, you see the old brick, but the community really drove the conversation. They said, we don't want to lose our character. We don't want to lose what we love about living in this community because of these old historic roads. So they ultimately chose permeable pavers. But before we get there, this was a really long 2-block stretch, and it had no drain inlets. So all that water was like a giant slip and slide that went down the different hills and ultimately filled the valley, flooding it. Almost any storm event was a flooding for this roadway. Still is today. So this one road didn't fix that problem, but it's part of that cohesive network. But ultimately, permeable pavers were chosen for this project for function and for character. So you start to see how the aggregates are filled in, compacted, construction gone through, number 2s to 57s, and then ultimately the finished roadway, which, if you recall back to that previous slide, looks very similar to the original brick that was there historically. The reason I chose this project to talk about is because in certain communities, we might have topography, as I do, to contend with for how do we deal with that with a permeable application. The main thing is not getting water in off the surface. We can do that pretty easily. The water is going to naturally flow through those open joints, through that aggregate. The driving solution that needs to be figured out is what do we do with the base profile down below? If we just let that water cascade the same rate and same speed down the slope at the sub-base level, it's going to build up right where this curb is and create a hydrostatic pressure. So in my opinion, we have to create some different solutions that slow that water, allow it to potentially infiltrate or slowly move its way down. So in this case, they ultimately build weirs and created little ponds that the water moves slowly down the hill. These are just some examples of what that can look like. There's various materials. I found another internet picture that kind of helps relay this. This is not my project, so I can pick on this a little bit. Two things I don't like about this. One, they don't have a geotextile separating the native soils from the aggregates. I think that's a big mistake. And two, that is a deep profile of all 57 stone. I like to see the larger aggregates at the base for our structural performance and not just build it all up with 57. So the reason I chose this is because I do like that weir that's just made out of rather inexpensive material, allows for the water to build up and slowly make its way through that opening. The second case study that I think is of importance is in Cleveland, and it speaks to water quality. So a lot of times we're so focused on volume and volume control and rate, but the second component that I think is really starting to become a concern in many communities is built around water quality, specifically for total suspended solids. So this is a hospital project. You can't see it that well in the image, but surrounding this peninsula of parking lot is wetlands. And one of the main concerns for this parking lot is water quality. How do we keep water out of the wetlands? How do we keep water at a high quality level? And really, that, like I said, is stemming from local ordinances that are including language of removing total suspended solids from the water before it gets to those different entities and they have to treat it. So they're putting the onus on developers and developments to remove those impurities. And that's what permeable pavers are able to do. So within a cross section, the aggregates, the limestone that we talked about, are able to break down those heavy metals, those oils and gases as it works its way through. Again, I'm going to draw upon my Pittsburgh knowledge, but old coal mines and old mines use limestone in the rivers to clean the water as it moves through. It's the same thing here, that as that water from the top with its impurities moves through those aggregate layers, the bacteria is doing the heavy lifting and it's breaking them down as they move through that cross section. So ultimately, we have cleaner water moving through than when it went in. This is just an example of what that large space can look like. And permeable pavers, and this is the benefit we'll talk about later on, can be this large space. So this is over 3 acres of permeable pavers in its entirety, parking stalls, drive lanes, etc. It doesn't have to be reserved for just the parking stalls. And I think that's one of the driving points I want to make for you is they're actually better across the totality of the surface, not relegated to small areas. The reason we're able to do permeable pavers in these large spaces is in tandem with the installation. And for me, in my community, a lot of people, when they hear pavers, they think the most expensive option. And the same thing was true on this project. Everyone thought pavers were going to be too costly, too expensive for the budget. And ultimately, it was the best option because of mechanical installation. So you can see this machine here. It's like a fancy golf cart with a really expensive clamp on it. I mean, this thing barely goes up hills, but it installs pavers really rapidly. So, you know, we'll talk about this later, but large swaths of hardscape surface are done rather efficiently because of machines like this. This is just an example of what that parking lot can look like. So some of the benefits we've talked about is just how we can incorporate the solution that we need for stormwater into the design, give the developer back space that they might have used for a detention pond, reduce maintenance. And I think we'll talk a little bit about that, but there's maintenance in everything. And maybe today you don't understand all the steps of maintenance, but that's something we can help you with later on in a direct conversation with your project to understand what the steps are and what it looks like. But I think from a permeable standpoint, from a design, It's about reducing impervious coverage and giving area back to treat that solution. So ultimately, we're giving that area back by the entire surface being a drain. So this is an example close up of one of our permeable pavers. The water only has to travel a couple inches before it ultimately reaches that drain, that surface opening that allows the water to move through. And what would the internet be if not for comic relief, right? Now we don't have to direct water to a drain and maybe mess that up or have the contractor mess it up in the field. This is not my picture. I'm really glad it's not. But ultimately, what I'm trying to prove this point is when we talk about permeable pavers, the entire surface area is a drain. We're not having to direct water to a specific area. This is kind of back to some of those points is that we have different products. They each have their own infiltration rate, and I can dive into deeper with this with you, but all of the initial infiltration rates exceed local ordinances for volume of water that will hit that surface based on intensity. So there's a lot of different design buzzwords that I just used there, but just know that all of the products that we offer far exceed the storm event's intensity. I think some case-by-case projects of more bad internet pictures are always important in that, generally speaking, parking lot trees are struggling for vitality and for vibrance because they're cut off from oxygen, they're cut off from water, and all of that is restored with permeable pavers. And we have some really great urban streetscape examples where, in connection with the landscape, permeable pavers help provide a more vibrant and vigorous solution to restore the natural environment within these urban situations. Touching on installation, I kind of touched on it a little bit with that large streetscape or parking lot project, but I felt like to better understand the reason permeable pavers can be done in these really large spaces is because of mechanization throughout the entire process. The top two pictures are two different methodologies for what's called screeding out the setting bed layer. The one on the right, called the ultra screed, is basically how they lay asphalt. It's a GPS guided system that sets that setting bed to a specific height and depth, and ultimately that's where we're going to lay the pavers on. Moving kind of clockwise, the bottom right for me is a different machine that's laying pavers. So you can kind of see again how that clamp is laying down roughly a 12 square foot area that's now making that much more rapid. The bottom left for me is like a giant toothbrush that's connected to this machine, and that's sweeping in all the joint material so that all of this is just done so rapidly. And that's the point, because when we reduce the manual labor side, increase efficiency, it also helps reduce cost. So the driving point for me is that not all pavers can be installed with this machine. We have to understand A, the application, B, the scale of the project, and C, what material we want to use. So there's different laying patterns and that are specific to the products, and we can help guide you to what the solution would be for that project. But generally speaking, these machines can install, upwards of 8,000 square feet a day. So we're competing with laying asphalt, for example, where now we have this durable solution within the pavers. Going to catch my breath for a second. Maintenance. Maintenance is one of those things that I think both as a designer and as we hand it off to the client, we have to understand what that next level looks like and help provide the information so that our clients ultimately take care of these, but also aren't fearful of what the maintenance looks like. Because whether they're doing it or not, they understand the maintenance in the asphalt parking lot, for example. They might not be doing it, but they at least understand that there's resealing, resurfacing that needs to be done periodically. Their mind is blank when you say, you might have to take care of this permeable parking lot we just designed for you. So we have some literature that can be helpful for that handoff, but I think it's imperative that we have that conversation as part of our design process so that our client has understanding of what that is. Maintenance is two things for me. It's in a lot of regions, it's winter maintenance, and just understanding that all the normal tools apply, whether it's plowing, shoveling, rotary brush, and de-icing. So de-icing is going to be done with salt, and just same rules apply, basically. We're getting into summer now, and nobody likes looking at pictures of parking lots with snow on it. But I think it's imperative to understand how the permeable paver works in a cold environment, because a lot of times when I first talked about this, people thought the ice froze on top, that created an impenetrable surface, and now we have no drains, and ultimately that's going to create a problem. The reality is, even a small amount of sunlight opens up these drains, these openings between the pavers, and allows that water to move through. Conversely, it doesn't have to find the gutter along the edge and try to find that drain that might still be clogged. This is just going to work as it would if it were raining, and all that water and snow moves off the surface. And we generally see less maintenance in the winter, less salt use, less snow plow, because this performance of the heat moving through the system from the bottom up and allowing that snow and ice to move through that system. That's just kind of an example of this geothermal warming from the base, allowing the surface to melt and allowing that water to fall through. The opposite end of that is a traditional asphalt parking lot that's just going to refreeze and require more snowplow and more salt to be used in order to clear that ice and snow. I'm just going to kind of skip to this. This is an example of that brochure I mentioned that kind of walks you through what the process of maintenance in terms of keeping these joints open and the system performing at a high level. I'm going to use two buzzwords that I think are the main takeaways: preventative and restorative. Preventative is like taking your medication. Restorative is saying, I didn't do anything, now I have to go to the emergency room. So if we do the small steps seasonally, which are more preventative minded, we can help keep these systems performing at a very high level. When we talk about permeable pavers, the first thing that I hear from a lot of people is, don't you have to vacuum those things twice a year? And the reality is, not usually. Ultimately, a vacuum is a good tool if that system is clogged or needs major repair, but that's the restorative part where we've basically let it go to failure and now need to bring it back to life. So I'll kind of move through this very quickly. This is an example of what it means to talk to your client and talk to who might ultimately doing some other lawn maintenance on site, because you cannot simply just dump the mulch onto the permeable pavers. That's not what we want. That's going to help advance clogging of that system. So the more we can communicate, the better we can identify how things need to be done. As this project evolves over time and kind of settles in, there might be small areas we call bird bath that get a little bit clogged, and we can just gently open up those aggregates with a broom and keep that system performing. The best friend, I think, to any permeable system is going to be just simply a leaf pack blower, so that as they do lawn maintenance and the grass clippings are there, they blow them off. As we see in my region, leaf litter accumulate in the fall, they just take care of it as it starts to happen on a weekly basis or something. The less organic material that we allow to filter into those joints, the more it's going to perform at a high level for a long time. Some universities and some hospitals have large expansive campuses, and they use rotary brushes to kind of help in the winter remove ice and snow. Wonderful. With a permeable system, they have to be mindful that they might be moving some of that aggregate out from the joints. While it's still like very pristine, we want to keep those joints full of aggregate. So we got to be mindful of the tools that the system uses and be mindful of what application we have designed for them. This is not a vacuum. This is called a regenerative air sweeper. And this is more for those large parking lots or roadways where this can run throughout the night. And basically what it does is it drives over the surface. It uses air that blows the dirt and debris and then is captured by this truck. So it's not moving the joint material, it's just moving the dirt and debris and leaf litter and whatever garbage might be on that surface. Moving into restorative. So in smaller areas, I wouldn't recommend this for an entire parking lot, for example, but like a sidewalk or something, you can help, or you can use a power washer and restore those joints by removing some of that sediment. And then finally, the last step is the vacuum. The reason I say it's the last step is because if we've done some of these preventative things along the way, we don't need to use the vacuum on a yearly basis. Well, it's a wait and see. It's an evaluate, it's an understand how it's performing, then decide if a vacuum is required, because the vacuum is a two-step process. When that vacuum goes across the surface of the paving, it is not only removing the organic material, but it's removing the joint material purposely. So now we have completely wide open joints, and the second process is we need to refill those. So that's why it's more of a bigger process for me. And I think ultimately the best case scenario for reason why pavers are so important is because immediately after any project is done, there's almost always a utility repair. Asphalt will always show those scars. Same with concrete. You'll always see where they trenched in, did their repair, and resurfaced. With pavers, you pull that space up, you make your repair, and you put that same material back in place. So that is kind of the end of what I consider to be the CEU portion. That's more the education. If you wish to stay on, I just have a couple more slides very quickly that I go through on Unilock and our resources, but also our material really quick. So for us, we make concrete, and this presentation is on one of our specific subjects in terms of permeable pavers. As I kind of alluded to throughout, that's not the only material we make, but we make pavers and walls. We do not make all things concrete, so I just want to kind of put that out there. I think it's really important to understand that, oops, sorry, I'm trying to move through there we go. I think it's really important to understand in a national audience like this that we take material throughout the country. So we have projects from Florida to Washington, from Arizona to Maine. We do not have locations in every single state. These are indicators of where our locations are. And from these locations, as we're building new ones, from these locations, we're able to take material throughout. So understanding who your local rep is, who your regional support is, we can help identify and be a part of your project no matter where it is. Maybe not Samoa. But one of the things I think that we do really well is have a lot of options, specifically when it comes to permeable pavers, and understanding that projects have different identities and different characteristics that we want to either match to or bring forth. And that's what we do really well in terms of providing options for these materials. We make concrete pavers to a higher standard. And I think that's one of the main differences from a lot of regional material is that you're getting exceptional quality in terms of performance combined with the aesthetics and options that we provide. So just kind of quickly moving through, we saw a couple of pictures of this one. It's an L-shaped paver. This is one of the ideal ones for the machine to install. So we do a lot of parking lots with this. I show this picture because, yes, you can certainly do line striping. It's a consideration that you can embed into your detailing, or it can just be painted on. This is another one that can be installed mechanically via a herringbone pattern. More of a traditional rectangle versus the L shape. Also has a larger square component. And we can do a lot of things with finish and color that we don't really get into in this presentation. So Ecoline is kind of the third permeable option that can also be mechanically installed. A very elongated linear running bond pattern. Here's an example in a parking lot where they put the permeable pavers in the drive lane instead of the parking stalls. I think this provides a really dramatic effect and a lot of bang for your buck. Eco Promenade, now we're kind of switching into hand installation. This is a much more elongated, linear. We're just showing it as a double herringbone. It can be a lot of different lane patterns, including running bond, multi-unit, staggered color to really accentuate this pattern. So Town Hall is a paver that has a really distinct character. It's made from historic Chicago roadway bricks, so it always looks like this reclaimed component or aspect. And we use this in Pittsburgh at the Heinz Lofts because those are 100-year-old buildings and it really fit in with the character of that space. The hex paver is something that we're seeing as a design trend, certainly a great option for permeable pavers. We did this all around the Nashville Stadium in 3 different finishes and 3 different colors to meet the pedestrian traffic use, etc., while providing the function for stormwater. Just some examples of how we can do some different blending, different finishes. Thornberry has more of like a natural stone character with some ribbon surface. Tribeca cobble, excuse me, you know, the streets of New York and streets of Pittsburgh have these really identifying cobblestones, and Tribeca draws upon that and gives this unique character. So that's a little bit on the products. Some of the resources that are available to you. We can do the BIM objects. We can do hatch patterns. We can do SketchUp swatches for you. You can reach out to your different reps and make sure that we get details for your specific project. One of the things I think is most important, whether it's online or through your local rep, is making sure that we get the specification correctly. This is the contractual language that the contractor is bound to. If we mess this up, we're messing up the project. So let's work in tandem and make sure the specification is exactly what you're trying to accomplish, and we can help deliver that for you and free you up to do other things. So that is a lot about permeable pavers. I'm going to stop sharing now and kind of open the floor up to Bo to jump in maybe.
All right. Awesome. That was really great. Thank you so much, Phil. I know we've got a ton of questions and a few moments left, so we'll try to get to what we can. And then for anyone whose question doesn't get answered today, we will have a record of it. We'll make sure we can follow up with you after today's webinar. All right, let's start off here. What percentage of water permeates through your products?
It's a challenging question to answer because it's really not put through that language. So when we talk about water moving through the surface, it's moving through the openings of the paver, not through the paver itself. When we talk about infiltration, it's generally in association with a rate, and that's a measured quantity based on a volume and a time. So there's a chart that we can share with you that better relays, and I kind of had it in the presentation, but there's a lot of information there that shares with you the rate of infiltration on the surface based on different paver type as it relates to a storm event. And the reason I say it references a paver type is because there are different pavers with different joint widths, and that's going to impact the infiltration rate for that particular type.
Right. Okay, awesome. So we've got time for 1 or 2 more. How do the pavers hold up to snow removal equipment?
Tell that this was asked before. No, I'm just kidding. Snow removal, the benefit here is that, you know, we are headquartered in Toronto. We make material for the harsh environment. So salt, snow removal, snow plows, all these things. That's why you choose a manufacturer that makes a high quality product, because when you have a lower concentration of strength within the material combined with a higher absorption, that's when you're going to see failure of the material. And what I mean by that is salt can be extremely abrasive, but the most detrimental thing to concrete is water getting into it, because that's what breaks it apart. So when you have high absorption, that means letting more water into the concrete. That's where you're more susceptible for frost damage, for failure, for salt to start to erode these materials.
Right. Okay, awesome. Since we have just 2 minutes left, I just want to remind folks who are still here to please grab any of those links from the chat that you might need, including the link to the quiz to receive credits for today's course. You will also receive a follow-up email from Zoom tomorrow that will also have that link to the quiz as well. But if you can grab it now, that's great. And other than that, I just want to thank everyone so much for coming out today. If we did not get to your question today, you can expect some follow-up from Unilock about the question that you were asking. There will also be a quick survey after today's event. So as you're leaving, if you have some time to fill out that survey, you can list any additional questions that might have come up for you there and give us some feedback on how relevant this course was to you. That'll help us to keep bringing content to you that is relevant to your practice. So we really appreciate all of the attendees for coming out and asking so many great questions. And thank you so much, Phil, for a wonderful presentation.
For the opportunity. Appreciate it.
Right. Awesome. Everybody have a great rest of their day. Bye.